video, we're going to look at the properties of logarithms. These properties apply to the common log log and the natural log ln. In your e-textbook, you can find all of these written out for you, and that might be helpful to see them typed out. I'm going to write them here as well for you. So the first question, it says, properties follow the rules of exponents. Why would this make sense? Love for you to think a moment, even to page back in your content guide and look up, what do logarithms give you? So what we learned is that logarithms give you the exponent. So when we take the log of 50 earlier in the content guide, we got the exponent to use on base 10. And we took the natural log of 40 earlier in the content guide, and we got the exponent to use on base e. So logarithms give the exponent. And since they give you the exponent, they behave like exponents. So let me fix my writing arrow here, and then we'll continue with the actual properties. There we go. They behave like exponents. So product. The first property, product, we know means multiply. And when we were multiplying, that meant we added the exponents. So what this is going to mean with logarithms is that when you multiply logarithms, you end up doing addition. So the way the property looks is if I have the common log, so log, of a times b, so that's the multiply, I can expand this to be the log of a plus the log of b. Just like we knew that if we had multiplication, we would add the exponents. Now, you can do the same thing with the natural log. So if I have natural log of a times b, that can be expanded to the natural log of a plus the natural log of b. The next is the quotient property. We know quotient is the word for divide. And we know that when we divided, we subtracted the exponents. So the way our property looks, if I have log of a over b, and the a over b has to be what I'm taking the log of, I can expand that out to be the log of a minus the log of b. And the same holds true if I'm working with the natural log. So if I have the natural log of a over b, I can expand that out to be the natural log of a. And I wrote the wrong thing. Let me just cross it out. Natural log of a subtracted by the natural log of b. Now, in this one, I wrote parentheses. Those parentheses could apply to the first one as well. So this a times b is in the parentheses. And it could apply when we expand it. So the log of a, that a is in parentheses on your calculator, the b is in parentheses on your calculator. Same way, whole way across. So when you type these on your calculator, this is what you're taking the log of, and the same with the quotient property. Now the power property, again, is going to follow our log. So the power, this is when we had exponents inside and outside the parentheses. And what we did was multiply. So same thing holds here. So if I have log of A inside my parentheses to the p power, which is outside my parentheses, I want to multiply. Now the multiplication here, just so we don't get mixed up as to what we're multiplying and what we're taking the log of, we typically put the p in front. So p times the log of A. And the same thing works for the natural log. So if we have the natural log of A to the p power, those are the exponents inside and outside the parentheses, so that becomes p times natural log of A. And so the A stays in the parentheses in both of these. And the p, we typically move it to the front so that we don't have to worry so much about the parentheses, but the p is clearly outside of the parentheses the entire time. This one is one that we use a lot in this course. The first two are used if we would go on to calculus, but since the majority of us are not going on to calculus, we are not going to spend a lot of time with them. But the last two, so this one that we just went over, the power property and the inverse property, we use these a lot in this course in solving. And so we'll be doing a number of examples, putting them into practice. And then the inverse property is based on the fact that exponentials and logarithms are inverses. And the key thing with inverses is that means that they cancel each other. So this is very much our concept of inverses, like multiply and divide are inverses. So when you go to solve an equation, the opposite of multiply is divide, and you can use that to cancel. The same is true with addition and subtraction, or squared and square root. So we have two ways of writing this. The first one is if I have log of 10 to the t power. Then this log 10 will cancel each other out, and that will just equal t. Similarly, if I have 10 and the exponent is log of t, the log and the 10 cancel each other out, and I just get t. So the reason why these cancel is because the logarithm produces the exponents for a base of 10. So that's how this all cancels. We also saw earlier that the log of 10 was 1, and so that's how this becomes just t. Same thing here. We know that the base for a log of 10 is 10, and so these guys, the base 10 and the exponent of log, also cancel. So in both of those scenarios, everything cancels and we just have t. Now we have the similar property for the natural log, but with the natural log we use base e. And so if we have the natural log of e to the t power, t being any number in the world, that will simply cancel to be t. And if we have the base of e with the exponent of natural log t, again, because they're inverses, that will all simplify to t. So again, we have, because this natural log produces the exponent for base e, these are true inverses cancel, and here the base and the natural log cancel. So again, we will use this property significantly in our work here at the algebra level. We will not be using the first two properties in this course because we are not preparing to go on to calculus where they would be important. But the property 3 and 4 there, the power and inverse property, are already important in college algebra.